Okay, so we have been talking about order of operations, right? Yeah? And today we're going to add in the piece of exponents, because yesterday, well, I was not here. Ms. Rivera should have worked with you guys on exponents, and you took notes. Can you ever remind me what an exponent is? Yep.
I can't explain what it is, but like, for example, 3 to the third power is kind of like 3 times 3 times 3.
Right? And what do we call that when we multiply? That's right. This is called repeated multiplication. So you should remember that. It's not adding. It's not multiplying 3 times 3, but it's 3 times. Okay? And we're going to practice that. So when I look at an order of operation problem, what's the first step that I always do? What's that first step?
Parentheses.
Well, we call it groupings. Okay, so we're going to check this problem for any groupings. Do you see any groupings?
There's one right there.
Yep.
Yes.
So we're going to underline it, and we're going to do that one first. What's 11 plus 4?
13.
That's right, 15. And then we're going to bring everything else down. Okay? Now, are there any more groupings in this problem?
No.
Nope. So what's the next step?
Exponents.
That's right, exponents. Are there any exponents in this problem? Yes, right here. So what I like to do is when I see an exponent, I like to write it what it should be out in expanded form, okay? So that I don't get confused. So anytime I see an exponent, I like to write it out like this. And then I just keep everything else in there. And so now I can do this. What is 3 times 3 times 3?
27.
That's right, 27. And so I'm going to take 27 plus 15 minus 28. So everything's just going to kind of stay there. And then what's the next step? Multiply and divide. Is there any multiply or divide in this, what's left of my problem?
No.
Nope. So I don't have to do this step. Okay? So then what's the last step of order of operations? Add, subtract. Remember, we always move which direction? Left to right. That's right. So if I'm going to go left to right, what's my first addition problem?
27 plus 15.
Then what do you get when you do 27?
42.
42. Good. So 42 minus 28 is left. Now subtract. Remember, we're just going left to right. This is all I have left. So what is 42 minus 28? 14. You might have to come over here and do this. Guys, there's nothing embarrassing about that. If I have to do a little scratch work, that's okay. Okay? What's 12 minus 8? It's 4. 3 minus 1 is 28. Sorry, it's 28. I was like, wait, that's not right. And it should be 14. So your final answer for this problem should be 14. Okay? So order of operations using exponents. Okay? So let's try the second one. This one looks a little bit more tricky. I typed this up very quickly, so just FYI, this star right here, yeah, it's really just like a multiply dot. Okay, so it's the same as yours. I couldn't get it to work the way I wanted it to. Okay, so what's our first step? Groupings. Are there any groupings?
Yes.
Well, this one's tricky because it looks like it has parentheses, but are there any operations in there? Nope. There's no operations. Are there any operations in here?
It's absolute value.
Nope. It's just holding the sign to it. No. It's not absolute value. Absolute value is straight lines. Okay? Absolute value is straight lines, so there's no absolute value. You will notice there's a difference. Absolute value has straight lines. Okay? So, are there any groupings in this problem? Nope. So what's my next step? Exponents. Okay, so I'm going to underline my exponents, and I'm going to rewrite it with the expanded form. So I have 15 plus 2, what does this mean? So how many 2's am I multiplying?
3.
3 plus 3 times negative 4. Okay? So now this is where I'm doing, what is 2 times 2 times 2? Yeah. What's 2 times 2? 4. And what's 4 times 2? 8. Okay. So I have 15 plus 8 plus 3 times negative 4. Okay. Are there any more exponents?
No.
Nope. What's the next step? Multiply, divide. Which order do I go? Left to right. Okay. Is there any multiplication in this problem?
Yes.
Yes. Yep, there's one right here. And what is 3 times negative 4? Okay, I hear a very hesitant, negative 12. What's 3 times 4? 12. So what's 3 times a negative 4? Negative 12. Okay, this is where you got to remember those integer rules. Okay, now everything else just gets dropped down. So I have 15 plus 8 plus a negative 12. Okay, do I have any more multiply or divide?
No.
No. Okay, what's the last step? Add, subtract. In which direction do I go? Left to right. Okay, so I'm going to start with 15 plus 8. What is 15 plus 8? Okay, 23. And then I have plus a negative 12 left over. Okay, so what's my last step?
23 minus,
So 23 plus negative 12, which can be also said to be,
subtraction.
yeah, it's just a subtraction. It's 23 minus 12.
11.
There you go. There's your answer. Okay. Any questions about order of operations? Okay. Tonight you are going to have homework. This page that says, why are dogs like phones? That's your homework. Okay. It's just practicing simple order of operations. It is self-checking. So right, because it has a riddle, and so you'll get the answer to your riddle when you're done. So go ahead and put this into your math folder so it's not in your way. You can also put your math warm-up, put your math warm-up also into your folder so that it's out of your way. And then you should just have 2 things left on your desk, okay? I'm going to pause the video so that you can get set for that. Okay, so now we finished our warm-up, and the 2 things you have left on your desk. The first one says prime factorization at the top, and it has some notes. And it looks like this. So this is where we're going to start today. We're going to take some quick notes. This is mostly a review from 5th grade. We have done this before. You know what a prime number is, a composite number is. So we're just going to write it down so that it kind of sticks into our brain, and then we're just going to practice some stuff, okay? Okay, so prime factorization. The first thing we need to remember is that when the numbers that we multiply together, what do we call those? Just numbers that are multiplied together.
Factors.
Very good. They're called factors. So that's going to be our first word up here. And if I look at this little problem, 4 times 5, 4 and 5 are factors. Okay? So then the next thing I have is that a prime number is a whole number greater than 1, which has exactly how many factors? How many factors does a prime number have? 2, right? It has 2 factors, 1 and itself, right? Do you guys agree with that? Yeah? Does that make sense back there? Yeah? Okay. What do we call the other type of number that has more than 2 factors? Yep, that's a composite number. Okay, a composite number is a whole number that can be made by multiplying 2 smaller whole numbers, each greater than 1. Okay? Now on Tuesday, when we did our chart with the colored cubes and we were doing prime factors, that's new, right? So we're just going to write that down so we kind of add it to our memory. A prime factor is a whole number that is also a prime number. Okay? So it's just a prime factor. We can have a prime number can be a factor. When I go back to this problem right here, which of these factors is a prime factor?
5.
Which one?
5.
Why 5?
Because it can only be multiplied by itself.
That's right. So 5 is a prime number. The next thing that we're going to practice today, and I'm just going to give you a brief definition of it, is called prime factorization. Okay? It is prime factorization, that's what we're doing today, is writing the factors of a composite number using a unique set of prime factors. Okay? Can't read that very well. Okay? The key thing is right here, it's unique. Every composite number has a unique set of prime factors. And that's what we're going to learn about today. Okay? Questions about that? So you might need to pause the video here to let everyone catch up if they need it. We are going to move on to this page. Okay? There are two ways that I know of that we can find prime factors. One of them is using this lovely thing called a factor tree. Okay? And it's called a factor tree because when you build it, it kind of looks like a tree with limbs, right? I built these for you, but you know, I'll show you how to build it by yourself. So when I have the number 90, 90 is a composite number, right? And I want to find the prime factors. I want to find what prime numbers can I multiply by to get 90, okay? The cool thing about factor trees is you can start anywhere. You can start anywhere with the things that make 90. So remember, when we're doing factors, that means what operation are we doing? Yeah, multiplying, okay? Because don't get confused and think that we're adding. When we're doing factors, we're going to be multiplying, okay? What are some ways that I can make 90 by multiplying? 10 times. Okay, 10 times 9. What else? How about 2 times 45? Yeah? What about 3 times 30? Yeah? Okay. Are there a lot of ways that we can make 90? Yeah. We're going to go with this one first. We're going to go with 10 times 9. Okay? So when you make a factor tree, this is one that's already made for you, but you just draw your limbs, and these are going to be your factors. So 10 and 9 are the ones we're going to start with today. You don't have to do this one on the side. I'm just showing you how to do it. Okay? It's the same thing that's right here. Is 10 a prime number?
No.
What about 9?
No.
No. So I have to keep going. I'm going to keep factoring until I get to the prime numbers. Okay? So what's a way that I can now make 10? 2 times 5. Okay? So you want to think of this factor tree as like a Christmas tree. Okay? And when I get to the end of a limb, when I get to a prime number, that's like the best gift, right? So we're going to decorate it like an ornament on the tree. We're going to put a ball around it. Only when it's a prime number. Okay?
And 5.
Yeah, 5 is prime too. Yeah, I just didn't get there fast enough. Okay? So 2 and 5 now become ornaments on our tree because they are factor. They're primes. Okay? Now, how do I make 9?
3.
Okay. Now, are those prime numbers?
Yes.
Yep. Okay? Now, this is where kids get stumped. They think, oh, I'm done. Okay? Now, you did find the prime factors, but mathematicians like things nice and organized. Okay? So we have to take our prime factors and we have to write them as an expression. Okay? You can do it below. There's not really enough room here. So I go and I take, they want you to start with the smallest prime number and go in order. Okay? So what's the smallest prime number? 2. So I'm going to write this as 2 times, what's the next one?
3 to the second power.
So hold on, I can do 3. What's the next one? 3. And what's the last one?
5.
Okay, so I can write this as an expression just like this. So go ahead and do this on your paper. So 2 times 3 times 3 times 5. Is there another way I can write this? Can I simplify it?
Yes.
Yeah, to what?
2 times 3 to the second power times 5.
2 times 3 to the second power times 5. Now why was I able to do this as an exponent?
Because there's 2.
It's repeating, right? Exponents are repeated multiplication. So I have 2 3's, so I'm going to do 3 to the second power. Okay? Now if I do the math, what's 2 times 3?
6.
And what's 6 times 3?
18.
And then what's 18 times 5? Let's just figure that out real quick. It's it's 90, okay? So every time you prime factor 90, this is the answer that you're going to get. Every time, because for this, it's unique to 90. This will never make another number, okay? All right. Now I want to show you that you don't always have to start with the same number. It doesn't. This is the cool reason for factor trees. Factor trees, you can start with any one, okay? So 90, what's another way that I can make 90?
2 times 45.
I can do 2 times 45. Is 2 prime?
Yes.
Yep, so we're going to make it an ornament. Okay. What about 45?
No.
Nope, so what are the factors of 45?
5.
So 5 and
7, 8.
a 9, right? Yeah. Is 5 prime?
Yes.
Yep, so we're going to make it an ornament. What about 9? 3 and 3, so we're going to make it an ornament. Are we all done?
Yes.
Yep. Did we get the same factors?
Yes.
Yeah. So does it matter where you start?
Oh.
No, because this one gives me the same exact factors. That's the cool thing about factor trees, is that they're very open. You can pick whatever one you remember, okay? So it doesn't matter. Okay, so the second strategy that you can use is called a factor ladder, okay? Now factor ladders are a little different. They're more structured. You have to start in the same spot every time, okay? And it looks called a ladder because you can see it kind of looks like a ladder, okay? So for this one, we're going to do a bigger number, because sometimes you'll be asked to factor out really big numbers, and you have to be able to do that, okay? So when I look at the number 504, I notice that it ends in 4, which means it's what kind of number? It ends in 4, so we know it's an even number. So I can divide it by 2, okay? So with factor ladders, you always want to start with the smallest prime factor that will work without any leftovers. So I know that 504 is even, so I can divide by 2. Well, 2 is going to go in here. 252 times. Okay, so I do my division. Okay. And now what's the next prime factor? Well, this is still what kind of number? Even. Still even, so I can still divide by 2. Okay. So now I have to figure out, well, what's 252 divided by 2? Okay. Okay, so I get 126. Now tell me about 126. Still even, so I can divide by 2. Okay, so now I have to figure out 126. Okay, so I get 63. Now, is 63 even? No, so I can't do 2 anymore. What's my next prime number? 3. My next prime number is 3. Is 63 divisible by 3? Yeah, it should be. Let's figure out what that is.
21.
Okay, so I get 21. Okay. Is 21 divisible by 3?
Yes.
Sure is. 7. How many times is it? 7. Okay. So we ask ourselves, is 7 divisible by 3?
7 is a prime number.
It's not divisible by 3, but 7 is a prime number, so what is 7 divisible by? 7, right? And what's left over? 1, okay? So on a factor ladder, your goal is to get to 1. When you get to 1, now you have all of your prime factors, okay? So now how would I write this as an expression? 2 ways I can write it. What's the first way? Kaylin.
3 to the third power times 3 to the second.
Okay, so you went to exponents. So 2 to the third power times 3 to the second power times 7. Okay, which means the other way I can write this is 2 times 2 times 2 times 3 times 3 times 7. Okay? So remember, I'm not done until I write an expression like this. Okay? Not done until I write an expression like this or using exponents. Now, remember, you have to be able to go back and forth. You have to be able to take a number like 504, and you need to be able to write it like this or like this. Okay? You also need to be able to take something like this and make it into the answer, or make it into an expression that's simplified using exponents. So there's a lot of ways that you can go. It's kind of like a spider web. Okay? Any questions? Okay, so now flip your paper over. And I copied it got copied wrong, so we're going to pick one. We're just going to do one practice, and then you're going to work on some task cards. Okay? Let's try 60. We're going to do 60. So everybody go to 60 you should have. Yeah, 60 as a prime factor tree you should have on the back of your paper. You should.
Oh, wait,
You should. So what is the way that I can make 60? I could do 6. Yeah, I could do 6 times 10. Do you have to do it my way?
No.
Nope. Could you do 3 times 20?
Yes.
Could you do 30 times 2?
Yes.
Yeah, there's lots of ways. Could you do 12 times 5?
Yes.
Yeah. Okay, will we always get the same answer?
Yes.
Yeah. So are these prime numbers here, 6 and 10?
No.
Nope. What are the prime factors for 6?
3.
2 and 3. Is 2 a prime number?
Yes.
Yep, so we're going to make it an ornament. What about 3?
Yes.
Okay. For 10, what are the factors of 10?
5.
2 and 5. Is 2 a prime number?
Yes.
What about 5? Yep, there we go. So if I rewrite this, it's going to look like this. Or I can see that this is exponents. It's repeated. So I can do 2 to the second power times 3 times 5. Either one of those will work. Okay? All right. So now you're going to work on some task cards. There are 16 task cards, but your paper, you will notice, only has 12 blanks. So are you going to do all of the task cards? No, you're going to work to do 12. Okay, that's your goal. You should have about 15 minutes left in class to work on these. Now, my first period, class was able to get through like almost all of them. If you practice, they get faster as you go. They're really not too challenging, but it's good practice, okay? You have to show your work, and you may work with a partner unless it gets too loud, at which point you will be working on your own, okay? And that is that.